stimulating panel discussion on AI and analytics, gearing for the computing demands of next generation AI application. So first it was computers, and then became laptops, and then smartphones, and then internet, and internet leading to a lot of data, and data leading to a lot of insights or AI. The democratization by using these tools and creating a lot of data has been at the center of our industry for the last decade or so. And the computing demands of training the next generation AI and machine learning models and application requires a huge amount of computing power. Some of the most processing power hungry applications of machine learning includes NLP, computer visions, recommender engines that deal with billions of possibilities on high resolution computer vision application used in medical and astronomical domains. Hence, the next generation of semiconductor chips would focus on efficiency and specialization. The discussion in this session would focus on how expensive, resource intensive machine learning and AI application can be democratized through the advances in the chip architecture and software center hardware design. So with this, we have a fantastic panel today for discussion. Mr. Bill Wright, head of AI, ML, and Intelligent Edge Global Industries and Accounts from Red Hat. Welcome, Bill. And we also have Mr. Xavier Kuriyan, Director Solution and Alliances, um, Global Compute and Network in India from Dell Technologies. Welcome, Xavier. We also have Dr. Shailesh Kumar, Chief Data Scientist and Head of Artificial Intelligence COE at Reliance Geo. A very warm welcome, Shailesh. So, before we set up on the requirements of the computing power and the chips, I would actually first like to go with Dr. Shailesh. Dr. Shailesh, could you give us some of the use cases that you're seeing, for a conglomerate like Reliance, on what types of use cases that you're looking to contribute to society with the advent of data and AI, and where do you see that technologies like machine learning and AI could really bring about change in our social culture and fabric? And please feel free to go down to the grassroots levels of impact to maybe societies or industries like agriculture or smart cities. So over to you, Dr. Shailesh.
Yeah, thanks, Sachin, and thanks, IMC, for organizing this panel, and delighted to be here. So, I grew up with the field of AI, and in the last 20 years, we have all seen a fantastic growth in, both algorithmic AI. The process has evolved, the hardware and compute has evolved, the use cases have evolved, the data types has evolved, right? So we have seen all that, and now we are sort of taking stock of where we are and how do we move forward. So let me give a perspective on the next 20 years where I think AI is going to be. And I think there are five key dimensions that I want to talk about. The first is, I want to talk about the revisiting of the fundamentals. So what we'll do, we'll be able to say that, look, deep learning is everywhere, a lot of compute is required, a lot of label data is required, but is this exactly how humans learn? Do we learn to see through a lot of examples? Do we learn to understand languages with giga word corpuses? Or there is something else going on? So one is, in the next 20 years, we are going to reinvent AI from first principles. We'll question everything what we have done and see whether, this, what I call brute force AI, which is, so much data, so many parameters, so much compute, is that the right direction, or we need to kind of rethink that? So that is one area of innovation that will happen. Second, like you said, in the last 20 years, we have done some amazing work in search engine technologies, advertising, marketing, social network, and recommendation systems. But the next 20 years are obviously going to improve what we have done, but they'll also add, social use cases like agriculture, healthcare, education, smart cities, sustainability. because until AI reaches the masses at this level, we have not yet really built a truly AI first world. So it needs to affect the farmers, it needs to affect the students, it needs to affect the patients and doctors, and it needs to affect security, safety, and citizens of the world. And that is where the next big use cases will emerge. A lot of work has happened, is happening in finding out the right use cases, the top use cases in each area. So, for example, in healthcare, one of the things we are doing is building, let's say the electronic health record of the country, using it to build what we call, health scorecards for the citizens, using that, and building a diagnosis as a service, because at least in countries like India, where doctor patient ratio is very different, how do we do accurate and timely diagnosis becomes an important problem, and can AI help with that, and so on and so forth. How about computer vision for all kinds of healthcare data, right? X-rays and MRI. So healthcare is a big area for AI. Genomics is a big area that is coming up. In agriculture, we want to think in terms of personalized advisories for farmers based on the complete ecosystem, right? Who is the farmer? What is the farm? What is the soil IoT data saying? What is the weather saying? What is the question farmer is asking? And combining all of that, can I give a very timely advisory to every farmer, which is very unique and different? Is going to be a massive ecosystem product, right? Same thing in education. We are still following a 200-year-old education system, which is teacher, classroom, one size fits all. Can we highly personalize education at scale and talk about a personalized curriculum for every child, a personalized content for every child, and a personalized, homework and solution for every child, right? So that is, if we can personalize Netflix, can we not personalize education, right? So this is how AI is going to swamp the social sector in the future, and our AI thinking has to evolve to come to terms with this kind of thing. So today we have mastered the art of building individual models, deploying them at scale. What we have not yet mastered is how to put together an entire ecosystem of 1,000 APIs. If you think about agriculture ecosystem, healthcare ecosystem, they are not like 5 API systems like Google search and all that. There are 1,000 API systems, smart cities, and there is no operating system for that. We don't know how to do this. So the next 20 years we are going to reinvent what I call product 3.0, which is these ecosystem products. And we'll reimagine what that operating system looks like, what role IT and AI are going to play in that ecosystem. And that's the third big innovation that will happen. And the fourth is, country specific AI, right? So today we have general AI, but when Alexa comes to India, they have to retrain their speech models for Indian English, right? And not only English, but India has 22 languages. So how about 22 other languages apart from that? And there's no, reliable models for that. So a lot of country specific, India centric, for example, or Europe centric, or whatever centric AI will develop. Generic models will not suffice. Country specific localization and personalization and customization at a local level, state level, city level, that kind of modeling will be the next thing. And the last is democratization, which to me means that anybody should be able to contribute to this 1,000 APIs requirement. No single company, startup, big company, or individuals can build all of them. So we all have to come together. We need a platform where we all can contribute. Sort of Uberization of AI will happen, where people will contribute AI APIs into that system and others can consume it. And it's a digital economy around AI, right? So these are the five dimensions, I think, where the future is. And we are very excited about it at Geo in contributing to such a future. Thank you.
Thank you. And it was a very comprehensive answer, Dr. Shailesh, and you did touch upon some of the real impact of AI to humanity more than just for the big tech companies focusing currently on search or advertisement, which was the first or maybe the second wave of technology. Uh, Before moving on to the next speaker, I would actually want to ask you one more question. Do you
Yes.
think we as nation or we as society, I'm talking about human mankind, are we prepared for taking upon this, one with respect to the hardware infrastructure that we're going to talk about, and second with the talent skill set that we have among us, not in pockets, not in scientists, not in few smart people, but more as a society, uh, to bring about this operating system of change, because each
Correct.
one of those things that you mentioned requires at least tens of Googles to really, uh, you know, be it like 1,000 APIs that you mentioned versus a five API machine, which itself is $1 trillion company. So, how do you really see that change in talent in terms of people? Can that society come about? Is it the right time, or are we talking a little too early?
Yes, very good question. And if you think about what a data scientist skill set was 5 years ago, what it is today is very different. And 5 years from now, the skill set required for a data scientist will not be around hands-on machine learning because that will be automated. It's already being automated. The next skill set for data scientist is what I call an AI architect for an ecosystem, right? What is an AI architect do? Like what is an IT architect do? He's different than software engineer. He puts all the building blocks and connects them together, right? So we need AI architects. We need solution thinkers. We don't need just model thinkers. We need solution thinkers who go out in the field. So AI does not start with where is the data set. AI starts with where is the pain point, right? And once we understand that, so the new training that we need to give to our next generation data scientists is become ecosystem thinkers, solution thinkers, design thinkers, right? Because the lower level skill sets that building a clustering model and all is done by machines automatically. But who is going to come up with the architecture of 1,000 APIs for agriculture, healthcare, and all that? How do we combine domain knowledge and data properties? How do we reinvent data streams? We cannot be slaves to the current data streams and say, this is all I have, so this is what I need to do. So today we work forward from data. We need to work backward from problem statements. This is the new skill that we need to develop. And then I think the next generation data scientists will be very, very domain savvy, not just data savvy. They will be system thinkers and not just model thinkers. And once we reach that, the definition of data scientists will morph into AI architects. AI architect is the next role. Data scientist job is going away, is my prediction.
Wonderful. So AI architect replacing data scientist. It's already quite a celebrated position that people strive to work for, and great to see the contribution of Geo at large to our nation in terms of building these products. You have commoditized internet, which is leading us to the next set of innovations which we are seeing in the country, which are happening. I'm very hopeful that this journey of innovation continues from the geo side. And thanks, Dr. Shailesh. I'll come back to you with more questions. Moving to the next speaker, Dr. Mr. Xavier Kuriyan from Dell Technologies. Xavier, suggest us or tell us what's the role Dell playing in the world of AI, and with the types of data sets, the type of art of possible that Dr. Shailesh spoke about, with respect to moving from a very simple AI, which was done for, let's say, a few parameters, and still becoming large businesses. Now we are talking about impacting the society at large, whether it is agriculture, healthcare, education. He touched upon many such areas, and each of these industries generates maybe zettabytes of data individually. And with this sort of compute power, which requires data to be crunched and made an insight of, I'm just optimistically assuming the AI architects and the ninjas have arrived, and what they have is the infrastructure that we have to offer today. What is the role Dell plays in the new scheme of things?
So Sachin, a couple of things. First, yes, there is that there is that vision of saying that that the world has to move to going and solving the bigger problems. AI today, however, is already on that path, and that path is being taken. At least what we see in the market is it getting taken in smaller strides, right? So, for example, if you look at healthcare, is there a way to take the mistakes of a radiologist out of the equation? In the case of pharma, is there a way to establish health of produce or quality of produce basis of photograph rather than rather than an expert? So it is specific pieces that are starting to come together. And you're absolutely right. The amount of data that is required to do some of these things is quite astronomical, right? Small things. I'll give you an example of a sentiment score that a video surveillance system that we came across can do. Every employee that's walking into an office, it'll give a sentiment score, and basis that you can establish productivity, you can establish risk, you can establish a lot of other things. And for example, in a factory which might be a dangerous environment, for example, a steel factory, it's very important to make sure that the people walking in are walking in with the mindset of working in that kind of an environment. It can contribute significantly to safety. um, and that's data, and that's video feeds. That is a lot of learning that has to happen, a lot of data that has to get stored, a lot of referencing that has to happen with different types of faces. So for example, South Indian face and the Northern and the Kashmiri face may be completely the parameters to look at might be very different. So even within the country there's a lot of data that has to get collated to be able to do something like this. Now, Dell as an organization has been in the business of putting these systems together for those customers that are starting to do these small pieces. And it's not only about collecting the data. We've built the systems on how to go collect the data. We've built the systems on how to store it, how to process it, so that you don't have to keep everything, right? What are the right pieces to keep? What are the algorithm? We've been working with a lot of partners, I would say, or even very small ISVs in the ecosystem, and helping them grow their environments. We've got small ISVs based out of a residential neighborhood in India that are running 400 node jobs on our cluster back in Austin, just to check whether this is something that will work. There's some phenomenal work happening on the application and the algorithm side. Now, while we're doing all of this, it's also important to talk about what hardware is there. And we've been working on putting together the right hardware, getting the certifications done for it, getting the application certified. And it's not just the big guys application certified, it's that small ISV working out of a house getting his applications certified, so that end users of that application will know exactly how to go deploy it. So it's been a fairly hectic journey over the last few years, but I think it's starting to come through with one. The world is moving towards faster data storage. The world is moving towards multiple options as far as a GPU goes. Right? Earlier there was realistically one option. Today you've got Nvidia, you've got AMD coming up with the MI GPUs, and at the other end of it, you've got guys like GraphCore that are making IPUs that are very tailored and specific to a function. And we are sitting and certifying each one of these options and saying that, hey, what's the right architecture to put together so that it works well. And I want to specify that word well, because it's very easy to get it to work. To get it to work well is fairly complicated.
Sure. I mean, great insights from you, Xavier. So, and I really see the role that Dell is playing in this whole ecosystem of AI. I mean, would you like to talk about with the chip shortage that is currently in the market?
Mhm.
How do you see that impacting the growth of AI uh, from a short to medium term basis?
Sachin, and it's impossible to go look at this from a 3 month window and say how it's going to impact something uh, in a 5 year horizon. Yes, there is a global shortage of inventory. Has it affected Dell all that much? We've been fortunate to be one of those few vendors that have managed to circumvent most of the problems. um, is Do options exist? Absolutely. And it's important to be and it's important for customers and people that are putting this together to start saying, do I really need this power? And I'll put this in perspective. The default a few years ago was to say that, hey, let me go put together a big cluster, and let's hope I need it later. Today it's important to be able to say, what do I need to get this function to work, right? And exactly that. Now it may very often it may end up being that you need the GPU or the IPU or the coprocessor only for learning, for inferencing. You may be able to do all of that on run of the mill CPUs, or maybe even ARM, small ARM machines that are sitting in a corner. It's important to be able to identify that and get to the right amount of compute that is required. General purpose compute, we've not really seen that much of a shortage. Yes, the times have been a little difficult, but it's not something that has really impacted the market as a whole.
Wonderful. And before I move to the next speaker, I would just like to ask one more last question from you, Xavier. What role do you see, Dell along with the cloud providers which are there to play in democratizing AI? Do you think the world cloud and the world AI has any sort of intersection together to
Absolutely.
offer it to the customer?
Absolutely. And the cloud the the cloud was the first step in going and democratizing IT, right? And I'm not just talking about the public cloud providers. I'm talking about every cloud that's out there in industry, and in people's industry data centers, and there's a whole bunch of clouds out there. The systems to link all of these cloud environments has already been established, right? The ability to go and commonize workloads so that you can run it on let's say on-prem for some time, burst it out to a public cloud, bring it back, send it out somewhere else. Those technologies have already been developed. The next step of data creation is going to start creating data at places that at today you and I don't think we can even think about it. For example, the amount of data that a car generates today is probably more than what a phone generated 10 years ago, right?
Yeah.
Let's be and cars 10 years ago generated tens to zero data, right? Uh, they generated maybe a few KB of data sitting on an ECU every life of the car. Uh, Today, cars generate terabytes of data, right? Self-driving cars generate so much data and that's very valuable data. So data is going to get generated in places that you and I can't predict. The next step of cloud is to go and start distributing that cloud. The telco service providers are starting to talk about it in terms of putting up small distributed clouds at the edge, or what they call near edge and far edge sites all across the country. Imagine being able to go and an AI, a full AI system at a store for a very short period of time. Run it. When the user moves out of there, maybe you don't need it anymore. Somebody else utilizes that environment. the system of how that those clouds are going to be set up is going to be is it is going to change, and it is going to change the way we create data, and it is going to change the way we consume that data, and where rather it's going to change the way where we consume that data. So cloud and AI, it's extremely important that both these concepts work together and create the architectures of the future.
Wonderful. I think the uncertainty, positively, I'm saying that the data offers this whole ecosystem offers that where all the data can be created is so unknown to us at this stage. A little is known to us, and still a lot unknown there. And the flexibility of the cloud, whether it is a public cloud or a private cloud, the allow the sheer allowance to really bust out into cloud and use a large amount of compute for the unprecedented data that may come makes this marriage more than real. I mean, a real made in heaven. That uncertainty and the flexibility come together and offer the companies, organizations a big edge to make
Absolutely.
it.
And I think the telcos, the telco service providers, uh, have a big role to play in going and creating this architecture so that compute at the edge can exist. So it's going to be interesting to see how this plays out.
Wonderful. And with the introduction to edge computing, and I would like to invite a new speaker, Bill. Welcome, Bill, to the show of ours. And maybe with the as applications of AI become more widespread, how do we prepare for networks that could meet the latency and the speed requirements of these applications? You have been doing this for Red Hat. Give us some view from what you're doing and how is it impacting.
Oh, thank you so much. And it's interesting. My colleagues have already touched on some really interesting areas for me personally over the last 5 years. And I think the preponderance of AI models across all these organizations today has created an interesting opportunity for the next stage of evolution for artificial intelligence. And when I when I heard about the 1,000 APIs, I couldn't help but smile because we've seen the same thing. Being at Red Hat, we're deep in the guts of the wiring of the data center and of these networks. And what's interesting to us, we've been working in the telecommunications field for quite some time, and what we've seen is this amazing distribution of AI elements all over the enterprise, both do it yourself and also supplied by vendors, but there's no unification, there's no cross correlation, and it's creating an amazing network opportunity when you think about it. Because if you could actually connect all these different applications and come up with a central cross correlation engine, which would be very complex, let's be honest, that would take some work, but to basically be able to take all that information and make sense of it, you really would have one of the first examples of a enterprise singularity, when you think about it, because you would be creating a single frame image of AI across the entire enterprise. And all these different AI applications are really like they're like compute nodes. I don't mean to oversimplify it. It's very complex programming, but it is interesting to me that I it's something Red Hat's working on right now. And we started a community called the Enterprise Neurosystem. It basically has that objective. Geo's involved with that. In fact, Ravi Singha has joined that community, and we're all working together in that direction. And our first project right now is with the Stanford Linear Accelerator, and Harvard Analytics is supporting that. And it's really a crossroads of academia, enterprise, and the vendor community to basically come together and look at this problem and find a solution. So it's not meant. This is an open source community. By no means is it a product. So I don't mean to do. I'm not trying to do a pitch of any kind. Really, what it is it's a way for us all to come together and start to look at the next version 2 or 3.0 of where this is headed. So that brings up a lot of interesting conundrums, because when you think about the processing at the edge in a POC we're working on with Stanford, they have a what they call a cookie box, and it's a detector, X-ray detector, basically at the end of the accelerator, and they have 20 different individual detectors that basically look for spatial information about the collisions that take place inside. And it really is a classic telco use case. I mean, when I heard the use case, us telco folks were all laughing because it was like, oh, we're going to have all this data at the edge and we have to process it at the edge and then we have to move it back to the neural nets at the center. And we all just sat there going, we've heard this conversation 200 times, and it's not to marginalize their use case, which is fascinating. I mean, it's pushing the boundaries of science. But over time, those detectors are going to go from 120 frames per second to over a million or close to a million frames a second. And to take that data coming in and being able to sift through it at the edge and then move it back in I guess you could say, in an organized fashion, it's going to be an interesting challenge over time. And that'll be in the next 2 years. So we're using this as a very small kind of, I guess you could say, a petri dish to test out the use cases. But I have to say, the other thing too is the chips, the advances in chips right now. I believe the Graph Core IPU has, I think, over 1,400 cores in the latest version, and it's fascinating to see that development. Going for what my colleague from Dell had mentioned, and the Graph Core folks are really they're really open and really fun to work with, and as are the Intel folks, as are the NVIDIA folks. I think we all realize this is a new frontier and we're all coming together to really try to address a lot of new problems in creative ways. So it's opening the door to a lot of creativity. I don't mean to get too esoteric about it, but it's an exciting time. I have to be honest with everybody here. I haven't had this much fun in my career ever. It's all the kind of interesting things we're all getting a chance to do. And the mobile networks have given us an amazing opportunity because I think the public cloud providers have always looked at it, with, I don't want to say hungry eyes, but they realize what that real estate represents. It's technical or technological real estate. And there's so many creative things you can do within that context. And it's opening up great opportunities for everybody in the ecosystem now. So yeah, I think this is one of those times every 20 years you see where you get a lot of innovation, that we're right in the middle of it. And it's been quite a bit of fun.
Wonderful. I couldn't agree more with you. And in fact, you answered one of my next questions, which I was eager to ask, but you've already answered, is about, this amount of data exchange with the edges, which is currently 10%, is going to go to 75% in 2025, how this is going to take care. But I think you pretty much answered that this is precisely is the problem statement which is getting solved. And with the advent of the speed of the networks, things are getting solved. So takes me to the next question. Large scale adoption of these applications require, operations of a wide network of data centers for commercial cloud services. How do you, I mean, sitting from San Francisco, how do you see India's preparedness for providing these services? Well, if you have any insight from there.
I actually, when I first came to Red Hat, one of the accounts I was asked to go and basically work with for kind of new initiatives and to do creative things with was not only Geo but also Airtel, and so I would come over to India quite often, or as often as possible. But I think what was neat about that is what I realized is that India had already made great leaps and advances in many respects in this particular sector, and what was interesting to me was the level of technical sophistication in India. And I think everybody there's an amazing level of education there as well. And so I think what's been interesting for me to observe has been India being at the forefront in terms of this kind of innovation. And it's funny because I think the United States in many areas, we're lagging also. We have to catch up in some respects. And we have to take a very careful look at how we as a nation are approaching things as well. But I think there's an interesting network effect taking place on a global scale. And all these different sub networks that are geographically dispersed really are just the foundations of what could be a global neural net over time. And I'm sure everybody, puts their hands in the air and talks about Skynet, and all those things. But, it really is like everything else. It's garbage in, garbage out. And so if you could look at that and could take that kind of a framework or infrastructure and use that as a foundation for climate change detection. I mean, very elegant, simple, but necessary use cases to help humanity. And I'm not an idealist. I mean, there are ways people might try to game a system or corrupt it. And And that's unfortunate because what's neat about it is, India has created these vast networks and all these other countries have too. If there was a way to utilize mobile networks in a way that could actually help us with these large meta frame challenges, uh, all the infrastructure is there. We just have to tie it together and learn how to trust one another, I think, and look for frameworks that can protect data, yet use the metadata to create, the model training necessary. There are all these different challenges that I think we can overcome quickly, but create a really interesting framework for good and global good. And again, I don't want to go too far askew. I wanted to answer your question, but I think what's neat about it is India has a vast amount of networking infrastructure now. And I look at that as one of those opportunities to take that into creative applications. And Geo is definitely at the forefront.
Thank you. I think Bill, very useful insight, and then great that you mentioned that India is well prepared. It's just about things coming together, the use cases coming together, and we delivering this to the society and the citizen. So with that, I'll actually come back to Mr. Xavier again for your last question, and then one with Dr. Shailesh before we conclude today's session. So, Xavier, tell us about quantum computing, and how is it going to impact in next 5 to 10 years is what you see, especially to country like India. But feel free to generalize it for
I,
the other use cases as well.
I wish I had a looking glass, Sachin, and if I could predict that to the fair sense of accuracy, I'd be investing a lot of money into it, right? There's uh, there is work happening towards that, to have a aware system rather than a learning system. Now, most of it is still research projects, but it is coming, and we know it's coming, right? We know it's coming because some of the architectures that we're seeing in both the algorithms as well as in infrastructure is starting to disaggregate, right? It's this You're starting to reach the stage at which you don't need more of IO, for example, or you don't need more compute. I'm not going to say compute because you could always use more compute, but there are things that are enough for a certain problem today. There are problems that there are very few of these problems now that are impossible to solve. It's just a question of how much you need to solve it, right? Um, are we going to see quantum computing pop around the corner tomorrow? I don't think so. Do we need to start getting prepared for this in a business? Yes, we do. We need to start thinking about what's going to happen 5 years from now, 7 years from now, 10 years from now, and start preparing for that eventuality where you can start looking at data sets that are significantly larger than what we can look at today. Short answer: I wish I knew, but it is going to be interesting going forward.
So I think we're living in times where the time to research to time to implementation has
It,
massively shrunk. Earlier it used to be decades before research could hit implementation. These days, I will not call it years, but in months, we see research delivering some real use cases for the world, and in
I,
years becoming
I'll give you
mainstream.
a classic example of that, Sachin. 10 years ago, if you ask somebody to go put up an application to go do whatever it may be, and this is not necessarily AI related, he'd say, well, we need to go analyze it, it needs to go through the board for approval, we'll think about it. Typical deployment timelines used to be 6 months, actually more, sometimes a year and a half, 2 years. Today, you've got organizations that say, hey, you've got an idea, build an application, roll it out, let's see, right? And uh,
Absolutely.
and 60%, maybe 80% of them don't work, but it's an idea that is getting tried. And that mentality of being able to do that is extremely important in the AI world, right? And what's happening in the rest of the IT world is also feeding that accelerated growth in the IT world.
Very well taken. I couldn't agree more with you. I personally have seen a culture of experimentation in my previous organization, which was Amazon, and experienced it. The more attempts, the more failures lead to higher and bigger innovation, and that's a thing that I take it to my clients, even from KPMG. Dr. Shailesh, last question for you. Um, you covered a lot of social areas. You covered a lot of areas where it would impact, society of India with respect to AI. How do you see economy reacting in the next 5-10 years? Let's say, if optimistically, the might of hardware, software, and creators, builders coming together. Where do you see economy getting impacted positively so in next 5 to 7 years, given that we are in the middle of data and AI world?
Yes. So I think, every time a new technology takes shape and, becomes popular, whether it's industrial, industry 1.0 to 2.0 to 3.0 to 4.0, every time, steam engine is invented, a complete new thing happens. Every time, car engine is invented, a new thing happens, right? So same thing in the AI world. I think AI is going to bring a lot of efficiency into what we do as a society. If you look at the supply chain efficiency that is needed, right? Today, there's a lot of waste of food because agriculture supply chains are not understood at a overall country level, right? Our policy import export decisions are not made in a data driven manner, right? How many hospitals do I need where and how many oxygen cylinders is not done well, right? The pharmacy, the medical supply chain. So supply chains will become a lot more efficient and data driven. That will bring down the cost of operations a lot, and it will reach a higher level of profitability. We could do a lot more with a lot less, right? So that is happening. uh, Precision and proactivity will happen, right? So proactive thinking will lead to a lot of avoiding certain failures, right? Like the life expectancy will go up because Fitbit can predict a cardiac event, or the loss of farmers' crop will go down because AI can predict that there is something going to happen. Student failures in exams will happen, can be predicted, and we can do corrective action. So predictiveness will go up at an individual level. Optimization will happen at a societal level. Efficiency will come, and with the less money, we can do a lot more. The second impact on economy will be that AI will create a new kind of economy, right? Labeling economy, modeling economy, AI first products, innovation, AI research and monetization of that research, model monetization. Imagine a world where, like today, Ola, Uber can, have democratized taxis. Now imagine that if we can democratize modeling and say, here is my model for speech to text in English or Hindi, and I want to compete in the world of this. And now I can be like a provider of AI, and I can monetize. Instead of going on Kaggle and getting a rank, I can actually start getting money into my bank account because my API is used by thousands of consumers on the other side for various use cases. So this kind of a new economy will come. So it will have twofold effect. What we are saying is it will bring in efficiency and proactiveness into what societies do, reduce the cost, increase our throughput, and second, it will create new kinds of economies where data labeling and modeling economies, which will be next level than just Java programming or web development, right? So the key is, will we as humans evolve and adapt to the new skill sets needed at the same pace, right? Are we reskilling, unskilling, reskilling ourselves at the same pace? And that, I think, if we can take care of, right? With the Geo Institute and many other institutes coming up, we are doing a lot of training in AI and data science. But again, it needs to be forward thinking, not backward thinking. And then we can start to create the right skill sets to create the right AI first economy instead of a mobile first economy or an internet first economy. See, when internet came, so much happened, right? Google search, ads, it just completely changed the scenario. Another 10x is going to happen because AI first thinking will come in every field. And there's a lot of work to be done. A lot of startups have to be created. A lot of big innovations to be had. So I think we are looking forward to a very bright future in terms of economic growth. AI will be an engine of economic growth in multiple ways. I think.
Wonderful answer. So completely agree with you that it's just not the efficiency, it's just not the productiveness, it's just not how it's going to impact the policy uh, implementation in India or in at an individual level. It'll also start to impact the creator economy and democratization of AI at all the grassroots level. So great conversation by this panel, Dr. Shailesh, Xavier, and Bill. I really want to thank you for taking this time out and be available for this discussion. It was a wonderful discussion. I would like to close it with an extra thought that while there is AI, whether it is cloud, whether there's chip requirement, and then now a lot that we're reading on Web3 with respect to blockchain and sort of a decentralization coming along, the requirements of the computing power that it needs to run the world has just gone massively high. And I hope the hardware providers, the software providers, and the implementers all put together and remain in the same sync to really develop and deliver what is needed to make a societal change in our ways of working. Thank you very much for joining us on this panel. Pleasure having you, all of three of you, and to our listeners. Thanks a lot. With this, thank you.
Thank you.
Thank you.
Thank you, everyone.